Hello third year, it's Miss McPherson again, back with another video on everyone's favourite bonding diagrams. Now I've had a quick look through some of the returns, or the hand-ins rather, for the covalent bonding exercise, and I thought it was actually a good idea to go back over the bonding diagrams just to make sure we're all on the same page about how we go about them. So, without further ado, we will get cracking. In order to get cracking, I need a pen. Pen. It's in red. I really want a red pen. Oh. There we go. Okay, so in order to do a bonding diagram, you need two things. You need to know the electron arrangements of the atoms that are involved in your bond. Please excuse my handwriting. So we need to know the electron arrangements, and we need to know the ratio of atoms in the molecule. So, first things first, let's consider good old hydrogen chloride. The elements involved are hydrogen and chlorine. Hydrogen has an electron arrangement of 1. Chlorine has a more complicated electron arrangement of 2, 8, 7. Now before we jump to the ratio of atoms, we first need to answer the question, how many electrons are needed for hydrogen and chlorine to have stable outer electrons? Hydrogen wishes to have the same electron arrangement as helium, which has 2 electrons, so it needs 1 more. And chlorine wishes to have the same outside electron arrangement as its nearest noble gas, argon. And argon's electron arrangement is 2, 8, 8. So chlorine also needs 1 more electron. To get our ratio of atoms, what we have to do is we need to swap these numbers over, 1 and 1. And this tells you how many hydrogen molecules, how many hydrogen atoms and how many chloride or chlorine atoms in our bond. In this case, we have 1 of each. So how do we go about drawing that? Well, hydrogen is very straightforward. It only has 1 outer electron. Chlorine, on the other hand, is slightly more complicated. It has 7 outer electrons. And it is drawn a little like this. So we have chlorine. It has 1, 2, 3, 4, 5, 6, 7. So when hydrogen and chlorine bond together, they bond together by sharing this pair of electrons. And this is how you draw it. So we have our hydrogen atom here with its single electron, and beside it we have our chlorine atom with its 7 outer electrons. And that, my dears, is the bonding diagram for hydrogen chloride. Okay. Alright then, so let's move on to something slightly more complicated than hydrochloric acid. We are going to have a look at the electron arrangement for water. Now, water is made up of hydrogen and oxygen. Hydrogen's electron arrangement is 1. Chlorine's electron arrangement is 2, 6. To have the same outer electron arrangement as its nearest noble gas, helium, hydrogen needs 1 extra electron, and oxygen, to have the same electron arrangement as its nearest noble gas, neon, which has an electron arrangement of 2, 8, requires 2 more electrons. In order to get the ratio of atoms in the molecule, we swap these numbers around. So in a molecule of water, we have 2 hydrogen atoms and 1 oxygen atom. Now this oxygen atom, because we only have 1 of it, that becomes our central atom, and it is drawn in the middle of our molecule. Let me show you what I mean. So, oxygen is going to be our central atom. It has 6 outer electrons, 1, 2, 3, 4, 5, 6, as just so. Now, these 2 unpaired electrons are where we are going to form 2 single bonds with hydrogen atoms. So in come our hydrogen atoms to form covalent bonds. Just like that. And here we have bonding diagram for water. Okay, let's do one more just for good measure. Let's do something slightly more complicated even than water. Slightly more complicated than anything that we've done so far. I am talking about something called nitrogen fluoride. So in nitrogen fluoride, we obviously have nitrogen and we have fluorine, N and F. The electron arrangement for nitrogen is 2, 5, and the electron arrangement for fluorine is 2, 7. Now, both nitrogen and fluorine, they want to be like neon, which, in case you've forgotten, has the electron arrangement 2, 8. So that means that nitrogen needs 3 more electrons and fluorine needs 1 more electron. To get the ratio for this molecule, we swap the numbers over, like so. So in a molecule of nitrogen fluoride, we have 1 nitrogen atom and 1 fluorine atom. Here is how we draw this out. So because we only have 1 nitrogen atom, we draw nitrogen in the middle. Now it has 5 outer electrons, so we do 1, 2, 3, 4, 5. So 1 pair at the top, 3 single electrons. Now each of these electrons are going to form bonds with an atom of fluorine. And it goes like this. So here we are going to draw our atom of fluorine. Now remember, fluorine has 7 outer electrons. 1, 2, 3, 4, 5, 6, 7. We do that exact same thing another twice. Sorry for my very wonky circle, guys. There we have nitrogen fluoride. NF3. Okay, so let's do one more just for completion. Don't like number 3. Gonna do a fourth one just for fun. And the fourth one that I'm going to do is I am going to do, my pen will work, carbon, tetrachloride. Now carbon tetrachloride contains carbon and it contains chlorine. The electron arrangement for carbon is 2, 4. And the electron arrangement for chlorine is 2, 8, 7. Carbon needs 4 more electrons to have a complete outer shell of 8. And to have a complete outer shell of 8, chlorine needs an extra 1 electron. To get the ratio of atoms in the molecule, we swap these numbers over. And we now know that we have 1 carbon atom surrounded by 4 chlorine atoms. Carbon, which we only have 1 of, becomes our central atom. So we draw it in the middle. It has 4 outer electrons, 3, 4. Each of these 4 electrons are going to form a covalent bond with 1 atom of chlorine. Let's start here. So as usual when I'm drawing my covalent bond, I'm going to draw the overlapping outside shells. And I'm going to do 1, 2, 3, 4, 5, 6, 7. For a chlorine outer electron arrangement, and I'm going to do that another 3 times. And we are done. For completion, we'll just mark these out as chlorines, and then we are officially done. So that is us done. If you have any further issues, if you're still not sure what's going on here, please get in touch. Please let either myself or Mrs. Grimes know, and we will do our very best to help you work through it. Take care, guys, and enjoy the rest of your week.